Nazywam się Robert Kuliński, mam przyjemność dzisiaj zareprezentować firmę Circle K, w siedzibie której jesteśmy. Zajmę tylko parę minut. Chcę, aby Państwo wiedzieli, jaką firmą jesteśmy i dlaczego akurat my organizujemy takie spotkanie dzisiaj. Circle K to nie tylko stacje benzynowe, to co się może kojarzyć jako pierwsze. Mimo iż jesteśmy firmą globalną i liczby mówią same za siebie, to z perspektywy dzisiejszego spotkania ma to o tyle znaczenie, że w takiej skali tworzymy oprogramowanie, więc są to rozwiązania naprawdę poważne. Jednym z rodziny rozwiązań, które tworzymy, to są aplikacje webowe, które przykładowo są to rozwiązania typu self-care dla dużych klientów biznesowych. Przykładowo, jeśli mają Państwo samochód służbowy, to zapewne w kieszeni jest karta paliwowa. Tę kartę paliwową ktoś musiał zamówić, wydać, skonfigurować. To są właśnie tego typu rozwiązania, które my bezpośrednio tu na miejscu dewelopujemy, używane przez klientów biznesowych na rynku. Skala jest międzynarodowa. Zwykle w zasadzie robimy rozwiązania, które póki co nie są używane w Polsce, więc jest to głównie Europa i Stany Zjednoczone coraz bardziej. Innym rodzajem rozwiązań są programy lojalnościowe. W tym celu również robimy portale. Z tym mogli się Państwo już spotkać. Mamy na przykład program Extra. Kolejnym typem rozwiązań, które implementujemy bezpośrednio tutaj, to są aplikacje mobilne. Te aplikacje są w różnych technologiach. Są to technologie głównie natywne, ale nie tylko. Przykładem tych rozwiązań są aplikacje, za pomocą których można płacić za paliwo w krajach skandynawskich, nie wchodząc do sklepu, posługując się wyłącznie aplikacją, która komunikuje się z pompą paliwową, wie, ile tych litrów zeszło i ile trzeba zapłacić i realizuje płatność. To są tego typu rozwiązania. Są to rozwiązania zarówno dla klientów prywatnych, jak i biznesowych. I to też ma duże znaczenie. Muszą to być odrębne rozwiązania, ponieważ ta dziedzina jest naprawdę inna. Inaczej się używa rozwiązań, które na pierwszy rzut oka służą do tego samego. Ale kontekst jest naprawdę inny. Technologie, ja myślę, że każda szanująca się firma technologiczna, tak samo jak Circle K Business Center, bo tak się postrzegamy, no tak naprawdę ten stack technologiczny będzie miała dość podobny. W każdym razie to jest zebrany zbiór rzeczy, które u nas w praktyce się stosuje, zarówno języki programowania, jak i narzędzia. I nie jest to zbiór kompletny, ale powiedzmy najbardziej widoczny w tym, co robimy. Tak się to odbywa. Poza tym wszystkim bardzo duży nacisk kładziemy na to, aby u nas się ludziom dobrze pracowało. Więc tak zwana kultura pracy, środowisko pracy, zasady współpracy, to jest coś, na co kładziemy nacisk, żeby to rzeczywiście było miejsce, do którego ludziom chce się przychodzić i chce naprawdę kawał życia tutaj spędzić. Agile, myślę, że już teraz standard wszędzie spotykany. Trudno mi powiedzieć, jak dużo należy o tym powiedzieć, ale tak naprawdę myślę, że wszyscy dobrze znamy to. Więc to również oczywiście u nas jest. Więc jeśli są Państwo zainteresowani firmą, szczerze zapraszamy odwiedzić stronę Business Center. Tam można znaleźć ogłoszenia o pracę. Również dzisiaj znajdują się na recepcji, więc zapraszam. Dziękuję bardzo.
Welcome everyone. Thank you for having me out. Despite my last name there, Czarkowski, I don't speak Polish, and this is actually my second time to Poland. My first time was only just early this year to Krakow. So I really appreciate you all having me out and also letting me speak English because it would be a much shorter presentation if I was speaking in Polish. So a little bit about me. My name is Paul. I am Australian, but I live in Austin, Texas in the US. And I'm a developer advocate at Pivotal. And what that means, well, first of all, I'm not actually a developer, which makes my position a little bit weird. I come from an operations background, so yes, I can do some Python and Ruby, etc. But I really come from the systems background. And I came into Pivotal specifically with a focus on Kubernetes. And then obviously we have a lot of Spring stuff going on at Pivotal. So I've sort of learned enough Spring so that I can talk about ways that we can integrate Spring with Kubernetes and get them working together. This is me. I already introduced myself. And so this is actually my real last name. And one of the joys I've discovered with visiting Poland is suddenly everyone knows how to pronounce my name. And they do it better than I do, which is interesting when someone corrects you when you try and say your own name. And so, yeah, I'm going to talk about Kubernetes first, and then I'll get into some of the Spring integrations. I'll intermix some live demo and other stuff as we go through. So Kubernetes, my friend Corey Quinn, super famous on Twitter, does a lot of snark about Amazon. Likes to say that Kubernetes is named after the Greek god of spending money on cloud services. And he is not wrong. You can indeed get into a lot of trouble running Kubernetes on the cloud. I certainly have when I've realized I've got like 30-something load balancers all running and eating up my Pivotal account. So you do have to be a little bit careful, especially when you're just testing stuff and developing stuff if you're using one of the cloud service providers. Or you can always run Kubernetes on your laptop using Minikube or Kind or similar if you're concerned about such things. Some people will tell you that Kubernetes is a container orchestrator. Some will tell you that Kubernetes is a platform for building platforms on top of. And really all of these definitions are correct because we have this kind of this listing of types of platforms. And you kind of start at that traditional hardware platform where really the people, your operations team, are the actual platform. And something like Jira is your API into that platform. And you have a lot of control. Like if you really care about the firmware running on the hard drives in your servers, you can have control over that. But it's super inefficient. And that's that traditional 6 months to a year of trying to get a machine out of IT, right? You come all the way to your application platform. So obviously Pivotal's Cloud Foundry, Heroku, stuff like that. You lose a lot of control. You have to write your applications in that very specific cloud-native way. You have to follow the 12 factors, but you gain a ton of efficiency. It becomes much easier to deploy your applications to the cloud. You can just do that CF push or Git push or Heroku push, and you just go straight from writing source code to having it run in production, which is really great. But sometimes you have applications that are not fully cloud-native, or you need more control over what's happening. And so we would used to go down to like VMs or traditional hardware for that. Now with Kubernetes and similar container-based orchestrators, we kind of have that middle ground where we can get a lot of control, but also retain a bunch of efficiency. So while it's not as easy to run an application in Kubernetes as, say, a CF push, it's certainly a lot easier than assembling a server by hand. And then, of course, I'm legally required to have this tweet up here. Like, if you're doing a Kubernetes presentation, you have to have at least one Kelsey Hightower tweet up on your slides. So just getting that out of the way. Yeah, so I kind of mentioned this. You have your application platform where you have a ton of efficiency. You just push your code and it magically runs. And then you kind of have your container platform where you've got to do a little bit more work to make stuff run. You can see I have a bunch of extra tools running that are either running inside of Kubernetes or running elsewhere to help me get a similar experience where I can just push code and get it running in production. Who here has used Docker before? I imagine most of us have. Yes, good, thank you. I can skip a bunch of slides. Do you all normally use like multi-stage Docker files these days to build your images? So hopefully you're familiar with this, yes. Pretty simple, starting with a fairly large JDK image to get my application compiled, and then I'm copying it into a smaller image. It's pretty good. There's a few inefficiencies. First of all, because the first thing we're doing is copying source into our image, we're losing the Docker caching. And also because we're doing all of this inside of a build image, we're also losing our own cache of like Maven, etc. So this is going to have to do like a full Maven install from scratch with no caching or anything of stuff. So it can take quite some time, 10 minutes or more if you've got a slow internet connection, just to do like a simple hello world. Oh, I have a couple of slides out of order. Hang on. Yeah, and so another way you can build images is there are several tools in the Java ecosystem. There's a really good one called JIB from Google, Java Image Builder, I assume it means. And they have both Maven and Gradle plugins. If you stick this in your POM and you run a Maven package or Maven install, it will actually build the Docker image for you. And it'll do it a lot more efficiently than even the Docker build with the multi-stage image. And you'll get still quite a small image. And you don't even need Docker installed on your machine. Basically, the folks at Google know how to construct a Docker image. And so therefore, they can do it without even needing Docker installed. Which means, like on your laptop, if you don't want to have Docker installed, or you have like Windows 95 or whatever, you're fine. And if you have a Jenkins server or a build server and security team is getting all up in your business about running an insecure Docker daemon on your server, again, it gives you another way of working around that. So these days, I tend to use JIB to build most of my Java-based images. And you don't even need this in your pom.xml. You can call a Maven command. And I might actually go ahead and do that. Is this readable? Can everyone read this? So I'll just play this so it's not actually going to be pushing images around. So you just go to your source code and you can do Maven install, Maven compile, sorry, and you can see I'm just including the JIB bits in, so I don't even have it in my POM. And it runs through fairly quickly, and you can see most of the stuff is in my cache, and it's already pushing the compiled image out to a Docker registry. So it all happens very quickly because I take advantage of all of the caching and everything already on my machine. So you kind of have two ways. If I don't have and I don't want Java on my laptop, I can use a multi-stage Docker build. If I do have Java and I don't want Docker, I can use something like JIB. So I sort of get a lot of flexibility, and I can choose which one I want to do. Either way, I'm going to get an image that's about, I think my basic Hello World app is about 200 to 250 meg for the container size, versus I was like at 800 or 900 when I had a full JDK in there. So it's definitely worth doing, because one thing with Kubernetes is you do end up pushing images around a fair bit, especially when Kubernetes is doing like auto correction of faulty images and stuff like that. So when you're using Docker, you've all seen these commands. They are very imperative commands. That's me saying, Docker, go and do this thing for me. And that works fine if you're on your laptop or just a single server. But when you get to production, and you might have tens or hundreds of servers, you might have hundreds or thousands of containers, obviously instructing Docker on every server to run this, that, or whatever becomes very inefficient. And that is where Kubernetes comes in. So Kubernetes, from a logical perspective, its infrastructure looks like this. Like any platform, it has a control plane and a data plane. The data plane is all the bits that run your application inside of containers. And the control plane is managing all of that. I won't go into detail over each bit because it's pretty boring, but there's these two things in the control plane, controller manager and the cloud controller manager. And I'll talk about them a little bit, because they're kind of what make Kubernetes stand out from the pack of container orchestrators and make it a little bit more than just something that will schedule containers for you. And really what they do is controllers, they look at the desired state. So when you ask Kubernetes for something, you give it your desired state of certain resources. And then it looks at the actual state of those resources, and it forms a loop and continuously watches the actual state and ensures it matches the desired state. So obviously when you do something for the first time, there is no actual state. So it will create the resources you want, and then it will keep maintaining it and keep watching it. If something happens, if there's a failure or something changes in the environment, it will see the abnormality and it will correct it. And so once you've sort of given it your desired state, you can kind of forget about it until you want to change what you're doing. And they usually follow that Unix philosophy of do one thing and do it well. So you can see quite small controllers that you tie together to do more interesting, complex behaviors, much like you do cat to grep to awk, etc. When you talk to Kubernetes, you use kubectl. So who here has used Kubernetes? Okay, so quite a few. So probably a lot of this will be somewhat familiar. You use kubectl to talk to Kubernetes. There is a dashboard you can use, but generally you only use the dashboard if you want someone to hack you and start mining crypto coins on your cluster. Generally you don't want that, so almost always in production you're going to be disabling that dashboard, and you're going to be using kubectl or similar tools to talk to Kubernetes. And it has these imperative commands that look very similar to your Docker commands, right? So kubectl run, kubectl scale, kubectl create. So very imperative, very instructive. I want you to do this thing. And this is great for when you're testing things out, when you're doing a demo up on a stage. But when you actually want to run something in production, you probably don't want to run these commands. You want to be actually using a manifest file and using Kubernetes in its declarative form. And so when you use a manifest file, either in YAML or JSON, you basically create the actual desired state of what you want in a document, and you feed that into Kubernetes. And that's really good because it means you have that configuration as code document that you can put into Git that you can use for your CI/CD workflow. You can do GitOps type deployments with it. And so if you're running things in production, you're either going to be doing it using kubectl apply and passing in a manifest, or you're going to be using a higher level tool like Helm or something like that. So speaking of manifests, this is what a Kubernetes manifest looks like at its most basic form. You can see we have the API version, kind, metadata, and spec. It's pretty obvious what they all are. Obviously metadata, I have a name there. You'd also have labels. And then the spec is literally the API spec of the resource that you want. So relatively straightforward, relatively easy to read in this kind of basic form. But when you actually run something and you see a real Kubernetes manifest, even for something as simple as a pod, it can get quite lengthy, and you have to be able to count spaces, which isn't always easy. So it's very easy to get something wrong and put a dash in the wrong place, the wrong indent or whatever. I will go through some of the Kubernetes resources that are made available. There's a dozen or more to do all sorts of stuff, but really the three main ones you need are pods, services, and volumes, and that'll get you most applications up and running inside of Kubernetes. Pods are the execution environment in which your application runs. So a pod is not a container. A pod is actually the insides of a Linux runtime that the containers run inside of. And they have a network IP address and local host that they share, and they can also share storage or volumes. And you can have more than one container in a pod. There's no real limit, but generally speaking, you have a one-to-one container to pod mapping. There are reasons you might need more than that. If you need to run something to transform a config file, or if you have, say, if you're running a PHP app, which it's 2019, you shouldn't be, you might have to have a PHP FPM container and an Nginx container and have them talk over a Unix socket either via the shared file storage or via the network. So that's a couple of reasons you might have more than one container in a pod. But you would never put your database in the same pod because that's a different scalable unit of your application. So, it might make sense for PHP to have two things in there, but you would never put your database in there. So that's important to think about. And I think we'll just get on to doing some actual live demos. So let's go straight back to my right here, make sure I'm in the right directory. So I'm going to run this kubectl create command. So I'm doing create deployment. I'm giving that deployment a name of hello, and I'm specifying an image to run, which is a very simple Spring Hello World app. So if I ask Kubernetes what all is running, I have K aliased to kubectl just for simplicity. You can see, even though I asked for a single deployment resource, I actually have 3 resources running. And that is because of the Kubernetes controllers. So there's a deployment controller, and that controller is responsible for the full life cycle of my application or my pod. That manages replica sets. And replica sets, the replica set controller is responsible for managing how many replicas or how many copies of your application are running. So it's handling the scale of your application. And then that then manages your actual pods, which is your actual application. And so if I run a scale command, you can see here I'm scaling my deployment to 6. And then I do my get all again. You can see I've got now have 6 pods in various states of running and creating. And you can see I still have that one deployment, and that deployment is managing the replica set, which is working to get all 6 running. So if I do that get all again, we'll see that 6 are running. Now, if something fails, if something goes wrong, and we'll simulate that by just simply deleting a pod out from underneath of it, the replica set is looking at the desired state, which is 6 replicas, and 1 disappears, so there's only 5, so it's immediately going to work to repair that. So if I do a get all again, we'll see there are still 6 running, and you can see there's that one at the bottom that's only been running for 15 seconds. So it saw it fairly quickly, repaired it fairly quickly, and within maybe even just a second, I had another copy of that application running. So that autocorrective behavior is really good and really important. And that's why when you're running an application on Kubernetes, even if you only need 1 copy, you usually reach for a deployment or a replica set because you get that autocorrective behavior. So if a worker node fails or something else happens in the cluster, your application will be repaired and restarted. Now, I mentioned that deployments are responsible for the lifecycle of your application. So we can go ahead and, oh, that was not what I wanted to do. We're going to go ahead and edit our deployment. So this is our actual, the live copy of our desired state inside the cluster. And you can see the actual pod spec is a lot bigger than what I showed you earlier. But what we're going to do is we're going to change something in our pod to tell our deployment that I have a new desired state. And so the easiest way to do that is to add an environment variable. And if I get my syntax and count my spaces correctly, so that's done. So now if I look at get all, we're actually going to see some interesting behavior. You can see I now have 2 replica sets, one of which is the older one, and you can see it only has 2 pods now being managed by it, where we have a new one in which it has 6 pods being managed by it. So what's happening is if we look up at our pods, the deployment is saying that we've changed our desired state. And so it's responsible for the life cycle of my application. So it's actually performing a rolling update of my application without me having to do any work. So it starts up a second replica set and sets its size to 0. And then it will start adding to that replica set while removing from the old replica set, always trying to ensure there are at least 6 replicas running until the old one is at 0 and the new one is at 6, which if we do our get all again, that should be the case. You can see we have the new one is now at 6 and the old one is now at 0. So that is Kubernetes doing a full rolling upgrade of my application without me having to do any real work, right? Back when I was writing Chef or Puppet, I would write hundreds of lines of the Chef DSL to try and do something like this, and it still wouldn't happen anywhere near as smoothly. So it's really good, and it's great that this kind of behavior is now just being managed by the platform rather than us having to recreate that behavior every time we try to deploy and write a new application. So clear up our screen. So here we have our application running. We've got 6 copies of it running, but there are no hints here on how I actually access my application. So if I want to validate that my app is working, it's not really clear how I do that. And that's where we can reach for a service, which I'll talk about in a second. But we can also, as an administrator of Kubernetes, as someone with access to the kubectl command, you can run this port forward command. So I can do a port forward. I'll pick one of the pods. And I know my app's running on port 8080. And so what this is doing is it's actually mapping in a port from my local host on my laptop up into the local host of the pod that I chose. And so if I switch, I can do a HPI 8080, and I get a response, right? So because I'm in the local host, I basically have full access to the application that's running. And you can see the environment variable I set, hello Warsaw, is the response we got back, which is kind of what I expected if the deployment had updated itself correctly. So that's great, and that's a way for me to verify that the application is actually running. And I can also do things in Kubernetes, like I can set a readiness check, and I can give it this URL, or give it the URL to like a health actuator, and Kubernetes will then start checking that my application is actually running and actually ready. And if it's not, it will actually try and restart my application and make it healthy again. So there's a lot of interesting behaviors that we get out of Kubernetes to help ensure that our applications are healthy. So that's port forward. But obviously, if I actually wanted people out on the internet to see my Hello World app because it's so wonderful, I wouldn't want to make everyone run a port forward command. I don't want them to have kubectl. I don't want them to have access to my Kubernetes cluster. So obviously, I need a way to get access to my cluster, and that is where services come in. So let's just move this along to services. So I'll run the command, and then I will talk through what is all happening. So I run this expose command. So kubectl expose, the name of my deployment. I'm setting type to load balancer, and I'm specifying ports. So if I now I'll just do a get service instead of get all, because that's all we really care about for this. So you can see here's my service running. You can see it is of type load balancer, and we have a cluster IP, and we have a set of ports. So what's happening there is when you create a service, you get this cluster IP, and that is an IP address inside of your Kubernetes cluster that load balances for all of the pods that service knows about. And so now anything else running in my cluster can now access my application via that cluster IP, or they can actually also access that IP address via the name hello, because Kubernetes has its own DNS server running inside of it, and any services are registered to that DNS server. So I don't even need to know that IP address. I can simply, from anything else in the cluster, access it via the URL hello, and it will get to where I need it to go. The ports, that long port 32121, that's an ephemeral port that is mapped from the external IP address of all of my worker nodes to that cluster IP. And so if you know the external IP address of a worker node and you know that port, you now have access to my application. But that's still too much information. I shouldn't be going out giving out random IP addresses and random ports and telling people to access it. And so that's where this type load balancer comes in. If I run this again, you can see we now actually have an external IP address. So the second controller manager in our Kubernetes diagram I showed is called the Cloud Controller Manager. And that will actually manage cloud resources underneath Kubernetes. In this case, it will actually create a cloud load balancer. This is running in Google, so in Google Cloud. And Kubernetes already knows the IP addresses of all the worker nodes. It already knows what ports it's assigned. So it can just go ahead and configure that load balancer appropriately to load balance for those. And then if something goes wrong, it will correct the load balancer. It will add worker nodes in and out as worker nodes come and go, etc. So now with this external IP, let me just make sure I don't have that port forward running. I can just hit that IP address. And so my application is now exposed on the internet. If you cared, you could actually go there on your phone or whatever and check that I'm not lying. And of course, you don't want to be using IP addresses, so you would put an IP address, put a DNS name around that IP. We can kind of simulate that just by using an XIP address. And so now I have a vanity URL that I can give to people, and they can access my application. So from nothing to having an application running and accessible to anyone on the internet. It's been quite simple. I haven't had to do a ton of work. Now, if we have a look at the actual service we created, I can talk about how it knows what pods it's load balancing for. So in our spec, we have a selector, right? And so the selector is looking for any pod with a label of app hello. And when I created the deployment, it created that deployment with that label. So here you can see we have label app hello, and then inside of the deployment is what we call a pod template, and in that pod template is this label app hello. So the service is looking for any pods with this label and automatically adding them to its load balancing behind that cluster IP. And that is how we have the automatic load balancing working, figuring things out. And that's also how, as I upgrade my deployment, my application will continue working and continue being load balanced as the deployment is rolling my application. So we also have what's called an Ingress Controller, and that actually lets you do higher level load balancing. Like if I have 100 apps running on my cluster, and I wanted them all accessible, I would have to run 100 services and 100 load balancers, and that's going to eat up a bunch of my Google dollars. So instead of that, I can reach for an Ingress Controller, and I can give it rules based on the host name or the URL path about what service to send traffic to. So this, when I run an Ingress Controller, it'll run a single load balancer, and based on the URL, it will load balance to a particular service. So now I can have a lot of applications running behind a single load balancer and save a few dollars, and I can make multiple applications act as if they were a single REST endpoint or a single website, which is quite useful. And then we have volumes. Pretty simple, really. It's just a directory that's mapped into the containers in your pod. They would usually share the lifecycle of your pod, so they'll come and go as pods come and go, which means they're not entirely useful, except if you have some ephemeral session data or whatever. But usually, when I'm using a volume, I'm actually using what's called a persistent volume. And a persistent volume will actually map a volume from like a block storage device, so Google Block Storage or an NFS or whatever, and that will persist beyond the life of a particular pod. And so if I want to run a database or something with important stateful information, I can use persistent volumes, and I can use them with what's called a stateful set. And a stateful set is just like a deployment, except it has ordered startup of your pods, of your replicas, and it has very specific naming. And so I could create a 3-node Cassandra database using a stateful set of size 3 and some persistent volumes. And so if I have 3 Cassandra nodes running, there'll be the Cassandra 0 will start up. Then when that's up, Cassandra 1 will start up. And when that's up, Cassandra 3 will start up. And so then I know what their names are, so I can tell them to cluster to Cassandra 0, and Cassandra will form itself up a cluster. If Cassandra 2, if the worker node it's on crashes or disappears, the Stateful Set controller will create a new one called Cassandra 2 and will map the same persistent volume up to it automatically. And so the repair happens quite quickly, and it doesn't need to re-replicate all of that data because it's getting that same data set that it had before. You can also mount volumes from config maps and secrets. Config maps and secrets are pretty straightforward. They are key value pairs that are stored inside of a Kubernetes manifest. You can create them from a literal string, like message equals hello S1T. So clearly, message is my key, hello S1T is my value. You can also create them from files, in which case the file name becomes the key and the contents of the file becomes the value. And then config maps and secrets, you can map into your pods either as environment variables, right, keys and values, or as files in a volume, right? So in this case, you would mount this as a file in a volume, and you would get an index.html file in the directory you choose containing that file. So these are really useful if you have either a bunch of environment variables you need to pass into your application to configure it, or if you have a config file that you need to pass into your application to configure it. You would reach for a config map. You can also, as I said, there's also secrets. You can see that looks basically the same. It's just you can't read the contents of the file anymore. It is not encrypted. It is base 64 encoded, and that is in case you have a binary secret like a key. We are working to make secrets encrypted by default. There's just a bunch of code that needs to go through to a GA release before we can do that. But you can right now integrate with things like HashiCorp Vault if you want truly encrypted secrets. So you wouldn't put your most important secrets into a Kubernetes secret right now, but you might put a password to a database that you would normally be putting in a plain text file anyway. It's not really any less secure than doing that. So that's config maps and secrets. Again, secrets like config maps, you can mount in as environment variables, or you can mount in as files in a directory. So I showed you editing, running kubectl commands, editing manifests, and that's fine for basic stuff. But if I actually have an application I want to deploy to multiple environments, I don't want to have to rewrite that kube manifest every time, right? And I don't want to have to take it and change it slightly and put another copy of it somewhere just so I can change like a database connection string. Because that's how I'm going to introduce errors, right? I'm going to do a copy and paste error. I'm going to do a wrong indent in one of the files and not the other. And so we have tools like Helm. And Helm is a package manager for Kubernetes manifests. So you can write and share Kubernetes manifests with other people, but it also templates them. So if you have small differences, like a different database connection string in staging and production, you can encapsulate those differences in Helm. It's pretty easy to get started with Helm. So let's go ahead and Helm create hi. So I now have a basic Helm chart already written. You can see I have a bunch of files there. I have a chart.yaml file, which is metadata about my chart. I have a values file, which is a bunch of default values. And let's just go ahead and edit that and change this to Paul Spring Hello World. And we'll go for latest, because that's how we roll. And I think that's all I need to change there. And then you have some templates. So I know I need to change at least one of these. So this is a templated out deployment. The double curly brace bits are the Go templating language. And I know I need to change a port value to 8080. Right here. And then if I want to get clever, I should also be able to template out an environment variable. Message, that should work, which means in my values file so with that done, I now have a templated out Helm chart which I can share on GitHub. I can also create a Helm package and share that via a Helm repository server, and then I can install my application using Helm. So we just released Helm 3. So let me double check my syntax. So I'm looking for the name. Let's give it a namespace. Hi, name, hi, and chart, and set. Equals hi there. So if I do this right, it should now install my Hello World app. Oh, I need to create that namespace. And then you can see it's actually printed out notes on how I can access my application. So we should be able to follow those. So that is my application running, and what name? So I can port forward into that. Ooh. Uh-oh. Okay, I got the image name wrong. All right. It helps if I know my own username. So I could just fix it in Helm chart, but just for quickly, I'll do that. Get all. See, we are now running. All right, so that was like me creating a Helm chart, making it work with my app, and again, that took a matter of minutes. Obviously, I know Helm, so it was pretty easy for me. But anyone getting started with Helm, as long as they've got a basic understanding of Kubernetes, should be able to write a Helm chart for their app without a ton of work. It is fairly simple, and then Helm will work with Kubernetes to manage the lifecycle of your application. There are tools like Helm File to actually help you join multiple charts together and perform like a GitOps style deployment workflow for your application. So that's kind of interesting, and that's how I, as like a sysadmin or an operator, that's how I would deploy applications, and that's how I would deploy the infrastructure that would build out the platform so that my software developers can get a friendlier experience, right? And can just run git push, and I run, Concourse and Spinnaker and whatever other tools, Jenkins, to actually do the hard work of actually deploying their application. I should be providing the kube manifest and everything to my developers, or removing their need to write kube manifest themselves, right? So that's kind of some basic Kubernetes stuff. And then I wanted to talk about the integration with Spring, and where we're at with that. So we kind of have two things. I mean, that was a Spring app I was running, that Hello World app, right? It was pretty simple, and I didn't need to do anything special. But if you are running a more complex Spring application, if you're using Spring Cloud Netflix tools, using Eureka and Hystrix and stuff like that, you can actually stop running a lot of those things. Because it turns out Kubernetes already knows how to do service discovery. It already knows how to run a config server. So why would you run those as well and then have to tie them back? So Spring Cloud Kubernetes is a way to bring those things natively to Kubernetes. So we get service discovery, we get like the client-side load balancing, ribbon stuff. We get dynamic config through config maps and secrets, so we don't need to run a config server. We also get profile auto configuration. So if you have a Kubernetes application properties file, and you run it on Kubernetes, it will detect that it's running on Kubernetes and will automatically load that. If you're running Istio or one of the other service meshes, Spring Cloud Kubernetes is aware of them and will help run inside of them. And then you have your actuators, your health actuator, etc., that you can use for your pod health. So there's a bunch of stuff you can start getting out of Spring Cloud Kubernetes beyond kind of the basic things that Kubernetes just does by default. So obviously service discovery, I kind of showed using via DNS, using kubedns, I talked through that. Services will also be available via environment variables in pods. So that's another way you can do service discovery if you don't want to use DNS. But if you're running in an environment where you have been using Eureka or other tools like that, or Zookeeper, it's pretty easy to use the Spring Cloud starter instead. Here you can see kind of the top of, I guess that's my, my POM, and then below is the application itself. And that's all you really need to do to run a discovery client inside of Kubernetes and use Kubernetes services as your service discovery method. And then load balancing, obviously, I mentioned services have that cluster IP, and that does load balancing for you. But if you want to do the client-side load balancing like you would get out of the Netflix tooling, you can run the Spring Cloud Starter Kubernetes ribbon. And again, this is kind of what your pom.xml would look like. And then this is an edge application that will basically load balance for any other service running inside of your Kubernetes namespace. And that tied together with the service discovery, this is all the app you need to handle doing that client-side load balancing, either in your app or in an edge type application. And then configuration, obviously I showed you config maps and secrets, and you can use those and they're great. But if you want to actually have a config server and you want to do dynamic reloading of your applications as config settings change, you can use the Spring Cloud Starter Kubernetes Config. And if you have the correct actuators for having a refresh endpoint, you'll find that your application can watch config maps and secrets and automatically load either a full application properties file or just keys and values into your application, and then refresh your application inside of itself rather than having to restart the entire pod or restart the entire application. And then you can, inside your Kubernetes properties file, application properties file, you can specify a list of config maps and secrets that you wish to read into your application. Relatively straightforward. And so these are just a few of the things we get, as well as the Istio and pod health indicators. So I'll actually go ahead and, before I actually demonstrate it, we also, if we add this, which is Micrometer Registry Prometheus, we also get automated metrics for our applications. So Micrometer Registry Prometheus exposes a set of about 150 metrics that Prometheus can read via an actuator endpoint. And when you run Prometheus inside of a Kubernetes cluster, it will look for any services or any pods that have a Prometheus-friendly metrics endpoint and will automatically start scraping those metrics. So if I have Prometheus in my cluster, any application I deploy with this enabled in my pom.xml will automatically start getting metrics collected for, which again reduces having to ask IT to start monitoring something or having to configure a separate monitoring server to start monitoring something. So while not specifically a part of Spring Cloud Kubernetes, this is definitely something I encourage people to run because you certainly get a lot of good use out of it. And then there are some JVM micrometer dashboards up on the Grafana website that will give you the basic access to those metrics, again, without having to do any work. So if you have Prometheus running in your cluster, you have Grafana running in your cluster, and you have applications with the micrometer endpoint running, it all just happens for you automatically, which is pretty sweet. But that does mean you have to run Prometheus and Grafana in your cluster, or someone has to. Preferably, you have a platform team or operations team that is managing Kubernetes for you and is providing those tools as a service, rather than everyone having to run their own Prometheus and Grafana servers. And then, that goes for really as an operations team or a platform team. It's on us to kind of build out this entire ecosystem of tools that either run on top of Kubernetes or beside Kubernetes, so that you all don't have to, right? And we should be providing the integrations so that you're just writing software, you're pushing that to Git, and something is running it for you. And they're probably going to be running not tons, but more than one Kubernetes cluster, either staging, production, testing, or maybe clusters per team or project, depending on how large the teams and projects are. So it becomes very important to use tools like Helm and to use GitOps type workflows for your infrastructure as well as your applications. And so kind of when I'm deploying Kubernetes clusters, I usually have 3 or 4 clusters running at any time. I have all of these things running on them, and I think the formatting on that's a bit wonky. But I manage it all via Git and via GitOps. I use a tool called Helm file that helps me do that. And so I kind of have one repo with all of my Helm charts in it, and then a repo for each environment and their specific settings. And I kind of just let Concourse do the rest by magic for me. So it's not that more difficult for me to run 6 Kubernetes clusters and all of these software on those clusters as it is for me to run one. So it's us as operators, as sysadmins, we need to be practicing the same things that you as developers have been practicing for a long time, and configuration as code, doing CI/CD on our platforms as well as our software, etc. And we need to do that so that you get this experience of you write code and somehow that code runs in production on this side here. So I think I had some more demo, so let's switch back to here. Okay, so I'm going to show off some of the Spring Cloud Kubernetes integrations. We still got plenty of time, right? Yeah, we do. Okay, good. So this is an app that was written that is basically emulating a shop. So we have 4 microservices. We've got like hot deals, best-selling fashion items, best-selling toys, and a gateway. So let's quickly look through some of our stuff here. So this is our fashion bestseller, pom.xml. You can see we have Chaos Monkey enabled, and you can see, hold on, let me clean this up a little bit. All right. Here we go here. So you can see I've got Spring Cloud Starter Kubernetes and Spring Cloud Starter Kubernetes Config, and I have my Micrometer Prometheus. And then in my actual REST controller, I'm pulling a value here. And so that value name is products. I have some defaults in case I don't put anything in my application properties. And it's fashion items, so shorts, shirts, pants, whatever. And then so when you go to /bestseller on that URL, you should get a list of best sellers. And then I have my application Kubernetes. So when I run this on Kubernetes, this profile will get automatically loaded. And you can see I'm making sure I have Spring Cloud Kubernetes enabled. I have my reload endpoint enabled. And I'm also disabling Eureka because I'm running this in Kubernetes. I don't need Eureka. I'm using Kubernetes to do it for me. So I need to make sure that there's no conflicts, etc. And then I also have a gateway application. It's fairly simple. It's got some routes and some circuit breakers in case there's a failure. And then I'm also enabling the gateway discovery locator. So any other services I have running in the namespace, it will load balance for them, even though I haven't specifically named them in the Java, right? So what this looks like on the cluster, I'll just switch to the right namespace. So you can see I have them running in my cluster. I don't know why I have that running in there. Let's pretend that wasn't there. So I have my fashion bestseller and my gateway. They're the two I'm going to demonstrate. And so I need to port forward into the gateway, and I have a cheat code up here for that, just so I don't have to type. So I'm going to port forward into the gateway, and then in a fresh window, I'm going to show you, I'm going to curl against that. Actually, we should be using HTTP because it's a little bit nicer. So the gateway is load balancing for the service. And note, these settings are not the ones that were set as the defaults. So clearly I have something set in an application property somewhere. And that is because as part of my deployment, I have a config map. And so we look at that config map. You can see here I have 2 keys I'm setting. So I could have an entire application.yaml in here if I wanted to, but I only really care about these 2 keys. So the first one is enabling Chaos Monkey. So if I curl a dozen times, I might see a failure, and it would drop back to my circuit breaker, which would just show an empty list rather than throwing an error. And then I have my list of products. I'm not a very good dresser, so I definitely don't have fancy pants. I don't have a fancy shirt, nor do I have fancy socks. So I get rid of those, and I will save this off. And then if we look at that again, so we've immediately updated, and we're seeing the new version of my properties. And if we look at my logs, so when you run Kubernetes logs, it will basically show you the standard out for the application running in those logs. And so we can actually see somewhere around here. You can see here, detected change in config map, reloading using the strategy refresh. And so that'll happen within a matter of not even a second, right? And so that's kind of an example of how we're tying in Spring Cloud and Kubernetes. It's not clear yet whether this is a great idea or not, because I'm now making my application reliant on the Kubernetes API, right? Because I'm reading config maps. So my Kubernetes application has to be looking at config maps instead of just getting them from a file in a directory, right? And so the 2 ways I configure my application, I do a config map and I mount it into a directory. My application doesn't have to be aware of the Kubernetes API, or I use this and my application is aware of the Kubernetes API and is asking the Kubernetes API questions. Maybe if I run a lot of Spring apps, I'm going to put too much load on the Kubernetes API. If the Kubernetes API fails, what's going to happen to my application? So these are things we need to think through. I do think that this is a good, interesting way to run things that maybe weren't written with the idea of running in Kubernetes directly, because we're used to using Eureka, we're used to using a config server, and so it's probably really quick to just add these bits to the pom.xml and we're good to go. But I think longer term we'll see more native use of config maps, and we'll be using it directly from the files, and maybe we'll have smarter ways of watching for changes on files on disk and reloading things that way. Same with service discovery. The best way to do service discovery in Kubernetes is using the Kubernetes DNS server. So while we can use Eureka, and there are some interesting reasons we can use Eureka, especially if we're doing client-side load balancing, I think ultimately we'll probably, for most applications, be using the Kubernetes native DNS. So there's a lot of discussion happening in the Spring community right now about how that's going to look going forward. Now we've sort of got this, we've got Spring Cloud Kubernetes working, and it works quite well. We're now figuring out if actually it's a really good idea, or if maybe it's good for small things and for demos, but in production we might be better off leaning towards the more native way of doing things. So that is running stuff in Kubernetes. That is Spring Cloud Kubernetes. And I thought I might show one more thing, which is it's like a 11-minute or so demo of actually performing like a GitOps style workflow of an application. I'm sure you're all familiar with the Pet Clinic app, right? It's kind of one of the canonical Spring examples. And so we did this demo for KubeCon, not the one just been, the one before, which was Barcelona, yes? And basically we wanted to show what it would look like doing a full GitOps workflow. We're using Concourse for the CI portion, and we're using Spinnaker for the CD portion. And then the workflow looks like this. If I commit to master, it's going to deploy to my dev cluster. If I then cut a release in GitHub, it's going to then deploy to my production cluster. In my dev cluster, I have just like a single replica, no database, so it's using the in-memory database. In production, I have 3 replicas with a database that has persistent data that's also running on Kubernetes and also managed by Spinnaker. And so that's kind of the infrastructure. And then Spinnaker and Concourse and Harbor are all running in an ops cluster. So we have 3 clusters running, dev, prod, and ops. So I'll go ahead and play this, make sure I haven't got sound on. And I'll kind of talk through it as it happens. So first of all, we're running PKS, which is managing these clusters for us, but that doesn't really matter. We're just kind of showing that we have those 3 clusters available to us. Here is the source code of our fork of the Pet Clinic, and we're going to modify one of the HTML templates because it's just a demo. We don't want to go too crazy, and so there's a page that lists the vets, I think. So this is our development cluster, and if you click on the veterinarians, you can get a list of the veterinarians at the surgery. And so we're going to change this page here. So this is the HTML template for it. Best practices, we're editing it directly in the GitHub UI, and we're just changing the title to KubeCon 2019, yeah, it was still this year. And again, best practices, just hitting that commit, no commit message. You know, no need to worry about that stuff. And then what we're also going to do to prove that it's acting correctly is, I mentioned that we're just using the ephemeral in-memory database for development. So we're changing Betty Davis's name to Betty Smith. When it actually does the deployment, it should change back to Betty Davis because there should be a new version of the in-memory database. So we modified our source in GitHub. Why is he clicking around? Come on, move on. All right, we modified our source, and so here is Concourse, and you can see it's already starting to build our image. So it's doing a Maven package, and when that Maven package is finished, it's going to do a Docker build. It's not doing a multi-stage Docker build. It's just copying the already built jar file from Maven in. And then when that finishes, it'll move on to the next stage of the pipeline. So pretty standard stuff. We hadn't mapped any caching of Maven or anything, so the build takes a bit longer than it should, but it has finished. And it was also running tests. So now it's going to build the Docker image. And then Concourse, just to validate, will actually pull that same image back down and check that it is the same image, just to confirm, because some Sometimes you run your Docker registry on like S3 or something, and it can take a little minute for it to get lined up. So you kind of just want to pull it and make sure it's actually there before you move on. So this is our Harbor registry. The new version of the image is there. And then in Spinnaker here, it's watching the Harbor registry, and it's watching the images in the Harbor registry. It saw there was a new version of the latest image, so it automatically kicked off the deploy to development. And in Spinnaker, we provide the kube manifest, which he just scrolled past real quick. And then we have a red-black deployment strategy, which is Netflix's way of saying blue-green. And that all happened quite quickly. So it has deployed the new version to our development cluster. And then we have the list of applications running that Spinnaker is managing. Switch across back to our dev instance, refresh, go back to the vets page, and we'll see that new version of the page is running with KubeCon 2019 written in it. He looks at the pets again, the owners again, and Betty Davis's name has changed back to Betty Davis because it's using that in-memory database, and it was a full new deployment of the pod. So there's a new pod, which means a new database. So that's that done. That's all the testing we need to do. So we're going to deploy it to production, and we do that by creating a new release. So we hit draft new release. We give it a version of 0.1.7. So we'll keep an eye out for that version number, and then we'll just publish it. No need for a message. And then again, that will then automatically trigger our concourse build. And I say automatically, it takes a few seconds because it's doing a poll. So it'll take 30 seconds or so to do it. So I think he's going to switch back to, where's he going to go? So yeah, so this is the production version of the application. And so we're going to verify it's still running the old version. So that's good. And then we have our owners. And this has a real database. And so we're going to actually modify. There it is. All right. So we're creating a new pet for Betty Davis. That pet's name is KubeCon because we're not very creative, and it's a lizard. So now, when the new deployment's done, because we're using a persistent database, both pets should still be there. Switch back to Concourse, and the build is happening. Now, because we're just doing dev and prod, we're going to go directly, we're rebuilding, right? Normally, you would go through staging, and you might promote a build from staging to production. Here, we're just doing a complete rebuild. So that'll be finished any second now, and we should see it push it up to the registry. Yep, that's done. And you can see the release tag 0.1.7, so it's aware of what was happening. Over in Spinnaker now, we're looking at our production pipeline, and there's our production manifest. You can see we have environment variables for the database and stuff, and we had 3 replicas set in it, but we scrolled through it too quick. Again, it's using red-black deployment strategy. If you're really good at doing deployments, you can do a canary deployment and connect it up to your metrics and actually watch and verify that your application is actually going to work before you move ahead. But again, this is too simple for that. And you can see it finished doing the push, and the pipeline finished in Concourse. In our Docker registry, we now have 0.1.7 of our image there, and it's actually already been scanned for vulnerabilities, and there's no vulnerabilities in it because we're not running struts or any of the other things that are scary to run. And so very shortly we'll see, and in fact right now you can see the deploy to production pipeline in Spinnaker is running, and that's going to update our application in the production cluster. And that should happen pretty quickly. And there it's finished. And so we look at our infrastructure view again. We look at cluster prod. It hasn't quite updated it there yet. But here is, you can see we have a set of ingresses and load balancers, ingresses and services. That's just tying our services and deployments together in Kubernetes automatically for us. And you can see we have MySQL running there as well. If we switch back to the clusters view, you can see in the production we now have that 0.1.7 version deployed, as Spinnaker sees it as version 37. And so now if we refresh in production, we now see the updated title, which means that we've sort of gone all the way to production on this. And Betty Davis, and she has that second pet we added for us, so our database is working correctly. So that's kind of that demo, kind of just showing what we as the platform operators, what we as the sysadmins should be building out, so that you as developers can just write code and use GitOps or similar methodologies to have your code deployed without having to write kube manifests, without having to run tools like Helm, and just really focusing on just developing your code. Yeah, and so that's about all I have. So thanks for inviting me here. Thanks for listening to me talk. Yeah, thank you.
How do you usually gracefully close the containers, applications, replicas you run?
Yeah.
For example, 6 replicas.
Yeah.
Let's say they connect to some other services, and you don't want to close that connection just by killing them.
Yeah. So
inform the application from outside to.
Yeah. So I mean, your application is just a process running inside the container, and when I kill a container, Kubernetes will send the process running in that container an appropriate, like, it's time to stop, and it will wait a certain amount of time, and then it will force it if it doesn't close itself gracefully. I can't remember the exact timeout, but it gives it a good couple of minutes to shut itself down gracefully before it will force the issue. So, you know, for the most cases, it's okay. If for some reason you had to, like, drain connections and it takes 10 minutes or 20 minutes, you might need to add some extra logic into how that's happening. And if you're doing that, you may be able to set different timeouts in the deployment manifest, or you might write your own controller specifically to manage that part of the workflow.
My question is about the space taken for Docker images.
Mm-hmm.
You show the demo, and each version produces a Docker image 100 megabytes.
Yep.
So I expect that after a successful day of programming, there are several plenty of images.
Yes.
And much of space is taken.
Yes. So on my laptop, so there's some Docker commands for managing, like removing images and stuff. On my laptop, on this guy, every couple of months, I just completely wipe the Docker images directory. And that's sort of fine for your laptop. In Kubernetes and running on servers, I feel like that hasn't been solved very well. And there's just kind of an assumption that you have an infinite amount of space. And that's not really the case. So one of the things we do for PKS is when we upgrade Kubernetes, we create new worker nodes. And so that's effectively killing all of the alt images that used to be in Docker on that server. So that's another way of handling it. There's no real good automated tools for doing it. So it's kind of on you to figure out how to manage it yourself. I have a number of times on like a Jenkins server or another CI server, it's blown up. Oh, why is it blown up? Because varlib Docker is like 60 gig of garbage. It's not unusual. So you have to just kind of build that hygiene in. It's not really automated at all in any of the systems. And then I guess if you're using a tool like Jib, because it's not doing anything with Docker at all, it's kind of skipping that behavior. It's just working with stuff in temp files, and then they disappear. So that's another good reason to use Jib. And if you can never have to run Docker on your laptop, then you're in a pretty blessed position. So that's kind of the goal, is to never even have to run Docker on your laptop.
Why don't you use dashboard?
You can use the dashboard. Why is my Slack up? You don't need to see that. Oh, you know what? I'll just close that completely. So the dashboard doesn't really, it's not super helpful, and it has admin permissions across your entire cluster. So if something manages to log into your dashboard, and for a long time by default, there was no username or password or anything for the dashboard. So any app in your cluster could access the dashboard and perform, deletes, run new images and stuff. So there's been a couple of famous cases of clusters getting hacked because they've had the dashboard running. Tesla was one good example. They had someone mining crypto coins in their Kubernetes clusters because of that. So you can run it if you want. There are some better tools that are out there that give you just like a read-only view if you want to be able to explore the topology of your applications that are deployed. There's one from VMware from the folks that were acquired in via Heptio called Octant, and that's really good because it's read-only and you run it on your laptop, and so it inherits the Kubernetes permissions that you have. And so if you have only access to certain namespaces, it then can only look at those certain namespaces. So if you want that visual look at what's running, you're definitely better reaching for a tool like Octant rather than for the dashboard. And also, who wants to point and click on things? It's easier to use a command line. Yes?
Does Zoom integrates now with Ingress, or it works separately?
Let me think. Zool. So I haven't used Zool on Kubernetes. I usually use Spring Cloud Gateway, and then that just using the Spring Cloud Kubernetes integration just integrates straight in and does that same client-side ribbon load balancing.
You should stop using Zool. It's under maintenance. Switch to Gateway.
Okay, so Gateway?
Yeah. So not directly. There is a controller for Spring Cloud Gateway that gives you a CRD, which is a custom resource definition that lets you basically write Spring Cloud Gateway routing rules as a Kubernetes manifest, and it will then configure Spring Cloud Gateway for that. But there isn't yet proper Ingress Controller written for Spring Cloud Gateway, and I think that's because Ingress is really just URL go here, URL go there. There's not a lot of intelligence behind it. So I think integration with service meshes like Istio is where we'll see that integration with Spring Cloud Gateway bearing a lot more fruit, because we'll be asking for a lot more complex things, circuit breakers, percentages of traffic to one place or another, and stuff like that. But I think a lot of that is still in the investigationary stage. I don't think we have a clear idea of where Spring Cloud Gateway and Istio and Ingress all really fit together. So generally, I see it as if something's coming from outside your cluster in, it should go through either a load balancer or an Ingress controller. And then if you want to, you could have that Ingress controller or load balancer pointing at Spring Cloud Gateway, and that would have a richer rule set to do more load balancing. Or if you're doing client-side load balancing inside the cluster, just go directly to Spring Cloud Gateway, or do the very simple stuff via services and cluster IP. But yeah, as Olga said, stop using Zool. And Olga's an expert at Spring Cloud Gateway, so she'll help you out. Mm-hmm.
use like general annotations for service discovery.
Mm-hmm.
So it gives some context to if we deploy to Kubernetes cluster, then it uses native components of Kubernetes.
That's right. Yeah. If it's deployed into Kubernetes, it will detect it and it will have the right thing in the Kubernetes. But you do have to disable Eureka, or you'll have conflicting config sections. Yeah.
If I do Eureka, I can use some configuration to decide whether to use.
Yes. Yeah, so you just have multiple Spring profiles, and so you might have a Spring Docker, you might have a Spring whatever your defaults are, and they would be using Eureka, and then they would have like Spring Cloud Kubernetes disabled, Eureka enabled, and then for Kubernetes you reverse that, enable Kubernetes and disable Eureka. And if you don't, your app will yell at you very quickly.
But if I have, for instance, two separate environments, one with Kubernetes and one with Spring Cloud.
Mm-hmm.
So if I deploy the same application to one, the other it should like detect the environment.
It should, yes. Yeah. But if you wanted them to talk to each other, like if you have stuff running in Kubernetes and also stuff running outside of Kubernetes, you might want to continue using Eureka so that you have like that overview of things running in and outside of Kubernetes. And so that's another thing we need to probably get a better handle on how we want to handle when we have that, like the 2 different or 3 different types of environments and how the integrations would look. So you might still want to run Eureka in that situation. All right, thanks everyone.